Let's look at solving some equations that are of quadratic form, but not necessarily quadratic. Actually, this first one here, it really is quadratic. I have x, and I'm squaring it, and I have an x that's not squared. We could multiply all this out. Multiply 2x minus 3 times 2x minus 3, see what we get. We could distribute the 7, we could combine like terms, and we would actually end up with a quadratic equation. Something times x squared plus something times x plus a constant. But that seems like a lot of work, especially when I can see I have something squared. It's not just x squared, but I have something squared plus a constant times that same something. I have 2x minus 3 squared, 2x minus 3 to the first power. So what I want to do instead of doing all that work and multiplying all this out is I want to make a little substitution. I'm going to call 2x minus 3, I'm going to rename it. I'm going to name it u. I'm going to make a little substitution. So if I call u 2x minus 3, then what I have here is that's 2x minus 3 squared. Now that's u squared. Plus 7 times, instead of 2x minus 3, this is what we're calling u. So that's 7u. Equals 8. And now that looks kind of like a quadratic equation that we're used to seeing. U squared plus 7u equals 8. Our main two ways of solving equations like this, quadratic equations, are factoring in the quadratic formula. Both of those require that I subtract the 8, so I have everything on the same side. So I'm going to say this is u squared plus 7u, and I'm subtracting 8 minus 8. 8 minus 8 on the right is 0. And now that is something that I can factor. So here we go. I need two numbers that multiply to negative 8 and also add to positive 7. And plus 8 minus 1 should do the trick. Equals 0. So I have plus 8u minus 1u is plus 7u. Positive 8 times negative 1 is negative 8. So we're factored. That's good. Now we'll do what we always do when we have something that's factored. We'll set each factor equal to 0 separately and solve those two little tiny equations. The first one, I'm going to subtract 8 both sides, and I have u equals negative 8. The second one, I'm going to add 1 both sides, and I have u equals positive 1. And that sort of looks done, except we haven't answered the question that was being asked. In the original equation, what we're looking for is values of x that make this equation true. What I have is values of u, which doesn't quite do it. So how do I get values of x? I'm going to substitute again the other way. So I'm going to take this u equals negative 8, and instead of u equals negative 8, I'm going to use my substitution. U is 2x minus 3, and I'm going to write 2x minus 3 equals negative 8. Says the same thing. That still says u equals negative 8. That's a little equation. I can solve that. I'm going to add 3 both sides. Negative 8 plus 3 is negative 5. And I'm going to divide by 2. So x is negative 5 halves. And that does answer the question of what values of x will work. I'm going to do the same thing with my other factor. U equals 1. U is 2x minus 3 equals 1. And I'll solve that. I'm going to add 3 both sides. So I have 2x equals 4. Divide by 2. 4 divided by 2 is 2. And there's my second solution. And I found both solutions to this equation of quadratic type. Another equation of this kind that we might run into might look like this. Again, this one actually is not quadratic. X to the fourth, not quadratic. Quadratic equations have the highest power of x is x squared, and that's x to the fourth. But what we do have is this is x to the fourth. I have an x squared here. X to the fourth is actually x squared squared, right? Multiply the exponents, that's x to the fourth, minus 4 times x squared, not squared, minus 32 equals 0. So here again, we can make a little substitution. I'm going to substitute. I'm going to call u x squared. So now my equation says x squared squared. I can rewrite that u squared. And then minus 4 times x squared, I can call that for u, x squared is u, and then finish it out, minus 32 equals 0. Here again, this is something that will factor. I can factor. This is my two binomials set up here. Two numbers that multiply to negative 32 and also add to negative 4. I think minus 8 and plus 4 will do the trick. So we got minus 8u plus 4u is minus 4u. Negative 8 times positive 4 is negative 32. Yep, that works. So now we'll set each factor equal to 0, just like always. That was supposed to say minus. U minus 8 is 0, and u plus 4 is 0. So this is u equals, I'm adding 8 both sides, u is 8. Subtracting 4 both sides, u is negative 4. Once again, we haven't answered the question that the equation was asking. The equation was asking what values of x make this equation true, and we have answered the question what values of u make this equation true. It's not the same question, but we can use our substitution in the opposite direction to answer the actual question. So here we go. U equals 8. So u equals 8 turns into x squared equals 8. Since u equals x squared, I'm going to write x squared equals 8. And that's a little quadratic equation. I can solve by taking square roots on both sides. I'll get x equals. When I do that, I get plus and minus. When I put in a square root that wasn't there before. The square root of 8, if we can simplify, we should. So we'll simplify that. The square root of 8 is 2 times the square root of 2. And that's 2 solutions to my original equation. 2 values of x that make that equation true, plus the 2 root 2 and minus 2 root 2. Then we'll take the other factor and do the same thing. U equals negative 4 becomes x squared equals negative 4. We'll take a square root on both sides and get x equals, again, plus minus the square root of negative 4. These are going to be imaginary solutions. The square root of 4 is 2. The square root of negative 1 is I. So I get 2 imaginary 2 complex solutions, plus and minus 2i. And there are my 4 solutions to this equation that was of quadratic form but not quite quadratic.